Okay, geometry, this is 1.3 using the midpoint and distance formulas. Your learning targets are you're going to find segment lengths using midpoints and segment bisectors, and you're also going to use the midpoint and distance formula. All right, things that I think you've learned before, so hopefully this is a good review. All right, first example, we've got a skateboard, and it says VW, segment VW, which is this segment here, bisects segment XY, the longer segment, at point T. All right, so if segment VW bisects segment XY, then we can I'll mark these congruent. This is how we mark things congruent in this class, with just a little hash mark. And yeah, it bisects, meaning cut in half. So this XT is congruent to TY. All right, and then it says that XT, this length right here, is 39.9 centimeters. All right, and it wants us to find XY, the entire distance. So this right here would also be 39.9 centimeters by the definition of bisector. And then we can add these together to find the entire length, which is 79.8 centimeters. And we're going to label that the distance from X to Y. If you recall, this is how we say distance from X to Y with no symbol over the top. And then I like to box or circle our answer so we know it's very clear what our answer is. All right, example 2 then. It says that M is the midpoint of VW. All right, so that means if M is the midpoint, then we know that VM here is equal to MW, which they're marked congruent here with these little hash marks. So we're all set there. It wants us to find the length of VM, which is just this part here. Well, let's set up an algebraic expression. So Vx, or equation rather, Vx minus 1 equals 3x plus 3. Since that's the midpoint, these two parts are equal, and I substituted right away, and now we can just subtract 3x from both sides. And we get x. We can also add 1 to both sides. X equals 4. All right, that's not our answer. I'm going to circle that because that's important. They wanted the length of VM, so that is VM equals, and I'm going to go ahead and substitute in 4 for x here. So it's going to be 4 times 4 minus 1, which is 15. 16 minus 1 is 15. So length of VM is 15. All right, example 3 says the endpoints of RS are 1, negative 3. So I'm just going to graph this. 1, negative 3 is right here. Here's the point R. And 4, 2. So up over 4 up 2 is S. All right, those are the endpoints. So here's my segment. All right. And they want us to find the coordinates of the midpoint. So the coordinates of the midpoint are somewhere in between, and to find that we take the average of the x coordinates and the average of the y coordinates, as you see from the midpoint formula. Okay, here's the formula for the midpoint. I'm going to label this like x1, y1, and label this x2, y2. You don't need to do that because these are interchangeable. As you know, addition is commutative, but I'm going to go ahead and label them and just plug them in here. So I end up with 1 plus 4 over 2, comma, and then I'll add the y's, negative 3 plus 2 over 2. All right, so this is 5 over 2, or 5 halves, 2.5, and this is negative 1 half. All right, so if you go over 2.5 and down 1 half, you will have the coordinates of the midpoint. So that is the answer for part A. All right, now part B is a little more tricky because they give us the midpoint this time and one endpoint. And we have to find the coordinates for the other endpoint. So I'm going to graph these just so you can visualize it over here as well. The midpoint they say is at 2, 1, so over 2, up 1. There's our midpoint. I'll label that M. And then one endpoint J is at 1, 4. So over 1, up 4 is J. All right, that means our other coordinate, if you basically just follow slope, you go down 3 over 1, down 3 over 1. We know our other endpoints right here. So it's pretty easy to get from the graph, the coordinates for K. But I want to use algebra here. That's the recommended tool because you're not always going to have such a nice, neat little graph where the points are close together. All right, so let's use algebra. The midpoint formula gives us the midpoint. So the midpoint 2, 1 is equal to the midpoint formula. So the midpoint formula would be, if this is 1 point, I'm going to call the other point x2, y2, or x1. It doesn't matter. I'll call it, just call it xy if you prefer. But it's going to be your x coordinates added together, divided by 2, and then your y coordinates added together. So 4 plus y2 over 2. So there is your midpoint. All I did was plug in the midpoint formula. This is my first point, this is my second point, and this is the midpoint. All right. Now what you can do is set these equal. So the x coordinate of the midpoint we know equals 2. So 2 equals 1 plus x2 over 2. Multiply both sides by 2, and you get 4 equals x2 plus 1. Subtract 1, and you get the coordinates for x2 are 3. All right. Which we can see here. This is the point 3, comma, and then the y coordinates do the same thing. Set the y coordinate equal to the y coordinate, and go ahead and solve that algebraic equation. So you have 1 equals 4 plus y2 over 2. Multiply both sides by 2. You get 2 equals 4 plus y2, and subtract 4, you get y2 equals negative 2. So the coordinates for y are negative 2, and there's your midpoint. So using algebra with the formula is the way to go, really, but it doesn't hurt to check it on the graph as well. All right, and then the last example, example 4, says your school is 4 miles east. Whenever I'm given directions, I always do north, south, and then west, east, just to make sure. Put a little compass on my paper because I'm prone to make mistakes. And then I kind of start from a starting point. I'm going east and then south. All right, so I guess I'll make a coordinate grid here, and this is my starting point. So the school is 4 miles east, 1, 2, 3, 4, and 1 mile south of your apartment. So this is my apartment, and this then would be the school. 4 miles east, 1 mile south. All right, a recycling center where your class is going on a field trip is 2 miles east and 3 miles north of your apartment. So 2 miles east, 1, 2, and 3 miles north, 1, 2, 3 would be right here. There's the recycling center. Okay, estimate the distance between the recycling center and your school. So what we're looking for is this distance here. All right. Now, if we give these coordinates, so we said this was 1, 2, 3, 4, negative 1 was the points for this, 4, negative 1. And we said the coordinates for R are 2, 3. If we call our apartment the origin. So now what we've done is we've graphed these points on a Cartesian coordinate plane, and we can now use the distance formula. The distance formula is the square root of the difference of the x's squared plus the difference of the y's squared. All right, so we subtract the x's. 4 minus 2 is 2. And we subtract the y's. Negative 1 minus 3. Order actually doesn't matter here, both in the terms of what you call your first and second point. Looks like I called this x2, y2. And I called this x1, y1. But it's hard to mess this up because when you square it, it's going to go positive anyway. So as long as you subtract and square, you're all set. And the order in which you do the x's and the y's can be flipped as well because it's addition, and addition order doesn't matter either. So it's pretty hard to mess up the distance formula. So let's go ahead and finish this. This is 4 minus 2 is 2. 2 squared. So I'm going to have here. And you can drop the parentheses if you want. And then this is negative 1 minus 3, negative 4 squared. All right, that gives me 4 plus 16. Don't forget to square this negative right here. When you square negative 4, you got to square the negative as well, so it becomes positive 16. So my answer is the square root of 20. And in a calculator, it says estimate, so we'll give a decimal. It's about 4.5, and the units we were using here were miles, if we round to the nearest tenth. So that's approximate. All right, I hope this helps. I hope the homework goes well. Once again, please let me know if you have questions.